Hello, this is your guide for Monday, June 8th in Work Packet 6. At the end of the video on Epic Books, we'll listen to a book about what scientists do and all the different kinds of science there is in the world. But first, let's do our work. So we'll start with our printing. Your name with your nicest printing. Put your name up here. So if your name is Doug, you would start with an uppercase letter. Your name always starts with an uppercase. And use the lines to help you make your letters. And your name isn't Doug, so please put your real name there so I know who did the work. And today we are practicing the number 5. So we start at the top, go across, down, and around. At the top, across, down, and around. Across, down, and around. Same thing again. Follow the lines. Try to make it your nicest printing. And yes, it is still printing even though it's a number. The whole point of printing is so you or anybody else can read what you're writing about. Okay, now we'll try it again by ourselves. So across, down, and around. Finger space, across, down, and around. Finger space, across, down, and around. That one's a little bit off. Across, down, and around. And finish the rest of that line and these lines too. Across, down, and around. Across, down, and around. Across, down, and around. Okay, and finish that off. And then down here, this is how you spell the word 5, F-I-V-E. So at the bottom, up, curve around, cross it over, I, middle to bottom, and then dot goes above the line, V, middle line, bottom, middle line, E, start in the middle of the letter, come up, touch the middle line, come down, touch the bottom. And again, same thing. F, I, V, E, F, I, V, E. And down here by yourself, F, I, V, E, finger space, F, I, V, E. And finish the rest of that line. If you look at the grid here, there's 10 boxes and it's the number 5. So we have 1, 2, 3, 4, 5 filled in. Okay, let's move on to our daily language review. And today we're looking at the word nails and how it can mean different things, like your fingernails or nails that you hit with a hammer to build a house or something like that. Daily language review. Look at the pictures, read the words. I see a hand and some fingernails. The word nails. Look at my nails. And here's some nails for building, for construction. Nails. Hammer the nails. Write nails in each sentence, then read the sentence. Okay, so on both of these blank spots, we will write nails. N-A-I-L-S. Down here too, N-A-I-L-S. And now we'll read the sentence. Number 1, Dad helped me cut my nails. You see the nail clippers? Number 2, Dad used nails to fix the floor. He's hammering in some nails on the floorboards. Look at the picture. Use nails to finish the sentence. Number 3, That's a dog's paw, and he's got some sharp claws or some sharp nails. My dog has sharp nails. Period. Number 4, I see Bobby. He's got a hammer and he's nailing a piece of wood to a table for some reason. And it says he used a nail. Oh, not a nail, because it's nails, plural. He used nails to destroy the table. I don't know why he's nailing a piece of wood to a table to destroy the table. Bad boy. Bad Bobby. Period. Okay, good. Story time. And today's story of the flute. Like the musical instrument that you blow wind into and then sounds come out. Please read the story and answer the questions. In this story, you'll see the digraph FL, fl, like flute, and flicker, flute, flicker, and float, Okay, what do we see here? We see a girl playing a flute, and she looks pretty happy. Question 1, what did Flo get in the mail? Number 2, what happened to the flute in the light? Number 3, what happened to Flo's flute in the water? Okay, let's read it. The flute. Flo got a flute in the mail. The flute was fresh and new. Flo saw the flute flicker in the light. Flo wanted to know if her flute could float. Flo put the flute in the water. It flopped. The flute did not float. Flo got the flute and put it flat to dry. Now Flo's flute was not fresh. Okay, number 1. What did Flo get in the mail? Flo got a flute in the mail. A flute. So it's the start of our answer. So we'll start with an uppercase. A, finger space, flute. Period. That's what she got in the mail, a flute. Number 2, what happened to the flute in the light? The flute was fresh and new. Flo saw the flute flicker in the light. The light. So the flute flickered. Flicker means you see the light bounce off of it. Kind of the reflection. It's shining in the light. It's a flicker. So what happened to the flute in the light? It flickered. Uppercase. It, finger space, flickered. So not just flicker, because it already happened. It's past tense. It flickered, because it happened before. Period. It flickered. Number 3, what happened to Flo's flute in the water? Remember she put it in the water? Flo wanted to know if her flute could float. Flo put the flute in the water. It flopped. That's what happened. We'll write it just like that. It flopped. Pretty much that means it sank. It flopped. It flopped. Period. Okay, good. Let's go on to our math. We've got some cool stuff to talk about today. We'll start with measurement. Remember we started to talk about measurement like centimeters, millimeters, meters, kilometers. So let's see if we remember what we were talking about. Okay, here's the word you need to know. Measurement. And in grade 3, you need to learn about length and distance. And these are the things you need to know. You got to know how to estimate, measure, and record length, height, and distance using standard units such as the centimeter, meter, and kilometer. You need to be able to measure really tiny things, small things, and really big things. Choose the most appropriate standard unit to measure length, height, and distance. You got to know, should I use my millimeters, centimeters, meters, or kilometers? And you need to compare and order objects using attributes measured in centimeters and meters. So I need to compare a 5 centimeter pencil to a 1 kilometer racetrack. You got to know, oh, that pencil's way, 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 way smaller. Okay, now let's look at the picture. We see a boy and a girl. She's standing on a stool, and the girl has a ruler. Looks like she's measuring the boy. And he's thinking, you're not quite 1 meter tall. And she's saying, see, we are both about 1 meter tall. But the boy knows she is standing on a stool, so she's not actually the same height as him. And he looks kind of grumpy. Grr. But she's just having fun. Okay. Down here, choose the best units to do the measurement. Write km for kilometer. Like when you drive to high level, it's 91 kilometers. It's a long way. M for meter. So remember we measured our room and it was about 15 meters across. Or centimeter, cm for centimeter. That's when I gave you your ruler, which is 30 centimeters long in the circles. So I did number 1 for you. And this is a racetrack for running. And the best way to measure that is with m, a meter. It's 1,000 meters, 2,000 meters. Because when you have a race, a lot of times it's the 100-meter dash, 200 meters. Okay, you don't want to use kilometers, it's too big. Centimeters, way too small. Okay, number 2, we are looking at a highway. Just like I said, driving to high level, what measurement are we going to use? Kilometer, meter, or centimeter? Of course, we'll measure that in kilometers. If you're ever driving, kilometers is the way to measure stuff. Number 3, here is a hatchet or an axe, and we want to know how long is it, the length. So why would we use kilometers? That's way too big. A meter, too big. We want to know centimeters, cm. You see how different measurements are handy for different stuff. Okay, number 4, it's a school bus. And look at the arrow. We want to measure the length, how long the school bus is. So that would be a lot of centimeters because it's a lot bigger than an axe. So meters. I would guess that bus is probably 8 meters long. Number 5, this is a map of the world. We live right here, and we're saying to get from Alberta all the way around the world to Africa, should we use centimeters? No way. Meters? Nope. Kilometers? Yes. If it's ever a really long distance, use kms, kilometers. And 6, we have a computer screen or a TV screen, and we want to measure the length across. How wide is your computer screen? No, it's not kilometers. Meters is too much. It's going to be centimeters again. cm. Cool. You see how that works? So what you really need to remember here is m for meter, km for kilometer, and cm for centimeter. If you can remember that, you're doing good. Okay. Let's go on to the next page. And we will talk about reading graphs. This one's all about how fast different animals can run. This one's in MPH. MPH means miles per hour. That's how Americans measure speed. But in Canada, we kind of borrow ideas from Americans. Like when we measure how tall we are, we don't say meters, we say feet. And when we drive, we say kilometers, but it's important to know miles per hour too. For example, I know when I'm driving 160 kilometers an hour, you should never go that fast, but I know that equals 100 miles per hour. Or you can think of it like this: 1.6 kilometers an hour equals 1 mile per hour. So miles per hour is faster than kilometers. Okay. Reading graphs. Use the graph to answer the questions. What's this graph about? How fast animals run. And the speed they run, 80 miles per hour, 70, 60, 50, 40, 30, 20, 10, 0 miles per hour. And the different animals: zebra, bear, cheetah, wild turkey, elephant, and elk. So, for example, the zebra, its bar goes up to 40 miles per hour. So the zebra runs 40 miles per hour. Or the cheetah runs 70 miles per hour. It's the fastest animal on Earth. It can't run for very long, but when it does run, it's super fast. Okay, number one, which animal is the fastest? We just saw the cheetah. It has the highest bar and the fastest speed, so cheetah. You can circle in the dot, or you can put a big circle around the whole thing. Number two, which animals run twice as fast as a wild turkey? Okay, so to answer that, we need to figure out first, how fast does a wild turkey run? Here's turkey, and this one goes between 10 and 20, which would be 15 miles per hour. And it's asking you twice as fast. That means 2 times. So 15 times 2 equals 5 times 2 equals 10. 0, carry the 1. 2 times 1 equals 2, plus 1 equals 3. So which animals run 30 miles per hour? Let's see. So here's 30, and I see bear, anyone else, and elephant. Those are the ones that run 30, which is double 15. So is that in our answers, bear and elephant? Not zebra and bear, bear and elephant, right there. So let's color in that circle and put a bubble around it anyway. Bubbles are nice. Number 3, how much faster can a cheetah run than an elephant? I did this one for you, and I'll just show you what I did. Let me erase all this so we can see our graph again. Okay. So how much faster can a cheetah run compared to an elephant? So we know a cheetah can run 70 miles per hour. That's why I put 70 here. And an elephant can run 30 miles per hour. So to find the difference, we subtract those numbers. 0 take away 0 equals 0. 7 take away 3 equals 4. So a cheetah can run 40 miles per hour faster. Last question, number 4. How much slower is a wild turkey than a zebra? So same kind of thing. we got to figure out, first of all, wild turkey can run 15 miles per hour. Let's just put that over here so we don't forget. Let's put 15. And zebra, what can a zebra run? Zebra's here, and it can run 40 miles per hour. So 40, and we want to figure out how much slower. So we need to subtract, and you need to put the big number on top. 40, take away 15. Start in the ones place. 0, take away 5. You can't do that. Cross out the 4, turns to 3. Cross out the 0, turns to 10. 10 take away 5 equals 5. 3 take away 1 equals 2. So, how much slower is a wild turkey than a zebra? 25 miles per hour. Wild turkeys are slow, but so tasty. Maybe that's why we eat so many turkeys, because they're easy to catch. Okay, next page of math. It's our number of the day. We're going up to triple digits today. And my number is 120. Okay, let's do this thing. One more. So we're going up by 1 in the ones place. So hundreds and tens stay the same, and 0 goes up to 1. 1 less. So because it ends with a 0, we're going to need to do a little bit of extra math. 120 take away 1. 0 take away 1. You can't do that. Cross out the tens. 2 turns to 1. 0 turns to 10. 10 take away 1 equals 9. 1, drop it down. 1, drop it down. So 1 less is 119. Plus 10. Now we're talking about the tens place. It's going to go up by 1 because it's only a 10. So we have 1, 2 goes up to 3, and 0 stays the same. 130. Take away 10. Now the tens place will go down by 1. 100 stays the same. 2 turns to 1, and the ones place stays at 0. 110. Okay, hundreds place. We have a 1. And 100 is 100. How many tens do we have? We have 2. 2 tens, 1, 2, equals 20, 20. How many ones? 0. 0 ones equals 0. 100 plus 20 plus 0. Start in the ones place. Zeros all the way down, going to be 0. 0 plus 2 equals 2. Drop the 1. So, just like we thought, it equals 120. Odd or even? Odd numbers end with 1, 3, 5, 7, or 9. Even numbers end with 0, 2, 4, 6, or 8. Our number ends with a 0, so put a bunch of check marks in the even box. Okay, hundreds place. We kind of already did this. If you look up here, hundreds, tens, and ones. So we don't really got to think about it again. We already know hundreds, there's 1, tens, there's 2, and ones, there's 0. Okay, good. Let me clean this up so we can see again. And round to the nearest 100. So we only have 2 options. We could go down to 100 or up to 200. And if our number is 150 or more, we would go up to 200. But our number is 120, so it's less than. So we're going down to 100. Okay, record on a number line. 0 to 1,000. In the middle of those two numbers, 0 and 1,000, 500. So that's way more than 120. So now let's break it down. 0 to 500 in the middle equals 250. Between 0 and 250, 125. That's very close to our number. So 120, we'll put it down here and put a bubble on it so I can see that's what you're showing me. What my numbers look like using base 10 blocks. So 120, let's use our place value chart. We need 100, put a circle on one of those, 2 tens, put a circle on there, and 0 hundreds or 0 ones, don't touch that one. Good. Record a number pattern starting at your number. So we start at 120. Let's go up by 5 today. So 120, 125, 130, 135, 140, 145, 150. My number in words, 120. 1, finger space, 100. And remember, there's no and. It's just 120. 120. And it ends with a 0, so we don't need to say 0. Just 120. Okay, great job. Stay tuned for Tuesday's video. And now let's go to Epic Books and learn about all the different kinds of science there is in the world.
Scientists Study Our World by Harold Morris. What do scientists do? Scientists study our world. Like scientists, we can learn about our world by observing and experimenting. Observing. Observing. Noticing by watching carefully. Let's find out more about science and scientists. Biology. Biology. Biology is the scientific study of all living things. Thanks to biologists, we know a lot about people, plants, and animals. Scientific. Scientific. Based on science. You can be a biologist. Chemistry. Chem is tree. Chemistry is the scientific study of substances, what they are made of, and how they react with each other. Thanks to chemists, we have life-saving medicines such as penicillin. Substances. Substance is powders, liquids, and solid objects. You can be a chemist. Oceanography. O-sha-nog-ra-phy. Oceanography is the science that deals with the oceans and the plants and animals that live in them. Thanks to oceanographers, we know which ocean plants and animals are endangered and how to help them. Endangered. Endangered. Plant or animal species in danger of having no living members. You can be an oceanographer. Astronomy. Me. Astronomy is the scientific study of stars, planets, and space. Thanks to astronomers, we know that there are 8 planets in our solar system and billions of solar systems in the universe. You can be an astronomer. Botany. Botany. Botany is the scientific study of plants. It is also called plant biology. Thanks to botanists, we know plants use photosynthesis to make their own food. Photosynthesis. Pho, to, syn, the, cis. A process that plants use to make food using sunlight, water, and carbon dioxide. You can be a botanist. Geology. G, al, G. Geology is the scientific study of our Earth, what it is made of, and how it works. Thanks to geologists studying and testing rocks, we know that the Earth is over 4 billion years old. You can be a geologist. Paleontology. Pale, un, tal, g. Paleontology is the science that deals with fossils and other ancient life forms. Thanks to paleontologists, we know dinosaurs lived on Earth for about 180 million years. Ancient, ancient, belonging to a time long ago, in this case, prehistoric time. You can be a paleontologist. Meteorology. Me, T, ral, G. Meteorology is the study of Earth's atmosphere, climate, and weather. Thanks to meteorologists, we know the daily temperature and when a dangerous storm is coming. Atmosphere. At, mus, fear. The layer of gases that surrounds a planet. You can be a meteorologist. Ecology. E, col, G. Ecology is the study of the relationship between plants, animals, and their environment. Thanks to ecologists, we understand how to better take care of our Earth. Environment. N, vi, run, ment. The natural world of the land, sea, and air. You can be an ecologist. Let's learn more. Here are some other exciting and important sciences. Seismology. Size, mal, G. The scientific study of earthquakes and their effects on our environment. Forensic science. Ren, sick, sci, uns. The science used to investigate and solve crimes. Microbiology. My, crow, by, al, G. The scientific study of all living things that are too small to see without a microscope. Entomology. En, to, mal, G. The scientific study of insects and their relationship to humans and the environment. Volcanology. Vol, ca, nal, G. The scientific study of volcanoes.
Wow, that's so many different types of science. If you could pick any one of those, what kind of scientist would you want to be? And those aren't all the sciences in the world. There's things like neurology, where you're studying the brain. And science is such a big, big world. And you have to work hard to become a scientist. You have to go to school for a long time, and you have to be dedicated and work very hard. But if you put in the effort, you can change the world. Like right now in the coronavirus, there's so many scientists working together to come up with a vaccine and help save the world. We need more scientists. Do you think you're up for the task? Think about it. You never know. Okay, good work today. See you on Tuesday's video. Bye, Wing Nutty. That's you. You're nutty. Bye bye, Wing Nutty. See you tomorrow. Au revoir.